So we're getting into Unit 2. We're going to be dealing with monomials and eventually get into polynomials. And we're going to be using what we learned in Unit 1 with the power of the laws of exponents and expanding that to solve different expressions and reduce them to more easy terms. Right, so before we do that, I'm going to review like what makes up a term. Okay, so remember, an expression is made up by, and an equation is made up by at least one term. Okay, now I can have, like an a to the cubed, b to the squared, c to the -3, all divided by y to the third, and then z squared, right? And my question is how many terms are in this expression? Well, there are no plus signs or negative signs separating any of these variables, so this contains really just one term. There's one term in this expression. There are many variables in this term, but there's just one term. Okay, now if I broke this up a little bit and I was like, okay, well, here is a 3 b squared plus c cubed, and this is all over y cubed z squared. My question now is how many terms do I have in this? Well, the answer is two terms. And technically this is broken down into a cubed b squared over y cubed, b squared y cubed over z squared plus c cubed over y cubed z squared, right? Because the common denominator, when you're adding stuff together, you can bind these two together and then remove the plus sign and just put the plus sign on top, right? These are the two terms inside of this, right? And these are equivalent because these are the common denominators. Just like you would say, like 5 plus 2 over 5/3. This is the same as saying like 5 plus 2/3, right? It's the same concept. Different terms, right? They're like terms over the same thing. So identifying the amount of terms is important so that you can know what is being multiplied together and what is being added or subtracted, right? Because it shows the number of terms. When you have things inside of one term, everything is just kind of like bonded together by multiplication or division. Everything in here is just smashed together with multiplication or division, right? And it all can be broken apart with multiplication or division. When you have a plus sign or a minus sign, like you could just change this to minus, right? That changes things. That makes this a term. Okay? Yeah, it makes it two terms. All right. Now, let's say I have another example. Let's say I have like z squared, c then minus 5, and y to the third, and I have a minus sign right here, but it's inside parentheses. Okay? This inside parentheses indicates that this is a -1 to the y cubed, right? And this is not subtracting it from the c to -5. This is saying this is negative y. It would actually be written like this. It would be negative y cubed. Sorry, that's how it would actually be written. And in this case, in this circumstance, say it's this over 3y, whatever, right? In this circumstance, this is still just one term. Okay, this is still one term, and I know this might be confusing, right? But this parentheses indicates that these are multiplied together. Okay, and this is just a negative form of y. Okay, and it's cubing the negative form of y. Okay, and it completely changes if I erase those, and if I just say this, it's completely different. Now it's two terms. This would change into z squared c to the negative fifth minus y cubed, and it would turn into this. Right? Isn't that crazy what parentheses can do? Right? It now changes into this. Right? That's completely different. So this does not equal z squared c to the negative fifth times the negative y cubed over 3y. Those are not the same thing, right? All because of those parentheses. Okay, so I just wanted to have you guys ensure that you understand the difference between and the importance of identifying the number of terms, right? So you know what you can and cannot multiply and subtract, or multiply and divide, and when you're combining your exponents, and you'll see why that's important, I guess, right now. Okay, so say, for instance, I have something like negative 3x cubed y to the fifth, and all of that is inside parentheses, and that quantity is cubed. Okay, so if I look at this, I have to distribute this cube into everything in here. But before I do that, I need to look inside of here and see if there's any work I can do inside of this parentheses. Because remember, please excuse my dear Aunt Sally, you do everything inside the parentheses first, then the exponent next, right? Well, everything inside the parentheses is done. Okay, right? So now, remember, this is negative. This is multiplication. I'm multiplying this negative to everything in front of here first. Okay, so it's going to be negative 9 cubed. Oh, sorry, it's going to be 9, right? So it's going to be end up 3 cubed, which this is not negative 9. This is not negative 3 cubed, right? This is 3 cubed with a negative sign in front of it. Okay, so this is 3 cubed, which is 27. Negative sign still in front of it. 3x cubed. Remember, when we have a exponent raised to another exponent, they're multiplied. So there's going to be x to the 6th, or sorry, to the 9th, because 3 times 3 is 9. Okay, and then it's going to be y to the 5th, and so it's multiplied. 5 raised to the 3rd is going to be multiplied, so it's going to be 3 times 5 is 15th. Okay, so that's going to be your answer there. It's going to be 27 raised, or that'll be your final answer after that gets distributed. Okay, so that is the exponent raised to an exponent rule, and then this is 3. This constant gets raised to the 3rd. Okay, so let's look at another example. Real quick correction. Sorry about this. When you cube this 3, the negative sign is indeed part of this. So it's going to be negative 3 cubed, which is still negative 27. So moving on to this one. All right, so I'm going to be squaring. So I'm going to take this one and do my first term. Right, so I'm going to be squaring this. Let me go ahead and distribute the 2 to the negative 3. So negative 3 squared is going to be 9, because negative when you square when you raise a negative to a positive exponent, or an even exponent, excuse me, when you raise a negative to an even exponent, it turns that positive, right? And then this is going to be w to the 3rd raised to the 2nd, so these are going to be multiplied. All right, so it's going to be w to the 6th, so So that's going to take care of that, right? So 20z is still going to be a thing, right? And then this is going to be 20 times -1, right? So this is going to be -20, right? And then z to the 14th, this is z to the 1st, z to the 14th is going to be z to the 15th. Now I still have to do 9 times -20. It's going to be negative 180 W6z to the 15th. Typically you put these in alphabetical order. So that is going to be the answer to that one. Okay, so here's one that's a little tricky. All right, so we're going to just start distributing here. We have 4 cubed, so 4 times 4 is 16. 16 times 4 is 64. Right, so this is going to be 64. And then we have x squared. So 6 times 2 times 6 is 6. Sorry, 2 times 3 is 6. 3 times 3 is 9. And then we have z times -2 is -6. So I'm going to go ahead and start myself a denominator. Again, how many terms do I have? This is all just one big long term. There's nothing joining these together. No plus signs or negative signs. They're just all one big negative term. So this is going to become z to the -6, or sorry, z to the 6th, because it would be negative on the top. So I'm going to put it on the bottom to make it positive. Okay? So then over here, this is going to be 4 to the negative, right? So 2 squared is 4, but the negative sign will put it on top as negative for the negative, right? So I'm going to put it on the bottom to make it on the bottom. Okay, the negative sign sends it to the bottom. X squared is going to send the x to the negative squared is going to send it to the bottom to make it positive. Okay, now I have y to the negative squared negative, so negative times a negative is a positive, right? So that's going to be y to the 4th positive, and then z squared times -2, right? So is going to be to the -4th, so it's going to be y to the -4th. Okay, wait, this is wrong. This is y to the 9th. Z, where do these 2 y's come from? That's a mistake there. That should be 2 times 3. Oh yeah, that's right. Okay. All right, great. That worked out pretty good. All right, so now I have this. Wait, that should be z to the -4th. It's supposed to be a z to the -4th. That's why I look funny. Right, z to the -4th. Z to the -4th. Okay, so now I can start consolidating and doing and combining like terms and like that. So 64 divided by 4 is 16, right? So my constant on the bottom goes away, on the top it leaves a 16. Okay, maybe I should do this in a different color. Let's do this in a different color. All right, so this goes away, and 16 divided by 4 is, or sorry, 64 divided by 4 is 16. Now let's look at my x's. X. All right, so I have 2 on the bottom. Those 2 go away. They take out 2 on the top, leaving me with x4th. All right, now I have, look at my z's. Well, on the top I just have y's. On the top they add, right? So it's going to be y to the 13th. Y to the 13th. Because 9 plus 4 is 13. Right? And then on the bottom, well, I can add these 2, right? This should be positive 4. That should be a positive 4. Because that's z to the -4th. So 6 plus 4 is z to the 10th. Z to the 10th. All right, so now I can just rewrite this as z, or 16, over x to the 4th, y to the 13th, over z to the 10th, or z z to the 10th, or you could write it as x to the 4th, y to the 13th, and z, that's an x, z, and z to the negative 10th, if you really wanted to just write it on one line. Okay, so that kind of just shows all the different ways to do that, right? If you really wanted to, right, you could have just moved, let's see, if I went back to here and I wanted to, instead of canceling it out this way, like the x and the x, say I had like, for instance, 16 x to the 6th divided by x squared, something like that. I'm just looking at the x's, right? I could, you know, move this up to the top and be like x minus 2, and then just add them together and be like 16x 6 minus 2 is 4, right? It would be the same thing, right? But you don't have to do it that way. I like to do I like to put all my I like to make everything positive and then just make my exponents go to war and cross them out. But this is, you know, mathematically equivalent too. So whatever method you prefer to do. Okay, so that is how you simplify one term with multiple variables with varying levels of exponents and constants. Okay, I hope that helps out there.